So welcome everyone. Welcome to the industry session of this QCrypt 2020. So as always in the industry session, we try to have a kind of feedback between all the communities to the more applied topics and industry. So so this should go both ways as always. So I might introduce myself. So I'm Christoph Marquardt from the Max Planck Institute for the Science of Light, and I'm chairing this session together with Akihisa Tomita. And when we designed this industry session from the steering committee, we thought it might be interesting that we give you some insight about what is happening in the world concerning two topics. Basically, one topic is standardization activities. So right now, quantum cryptography is so advanced that there is a lot of activities right now worldwide concerning standardization and even certification. And so there will be one session about that topic this morning. And another session will be about activities, worldwide activities about quantum networks, or QKD networks, where one really tries to investigate quantum cryptography in realistic networks. And so this will be part of the second session. And we are quite proud that we got some excellent speakers that will give us talks about these topics. And I will start right ahead. Now, I will say we have those talks, and about 10 minutes talks that will update about those different topics. And then there will be time for about 5 minutes questions. I will try to coordinate a little bit the questions. As always, there will be more questions probably. Then there's always time to ask the speakers afterwards in the breakout sessions in the meeting greet rooms. And in after those talks, there will still be a little bit time to for discussing a bit more general topics, because I think it's nice to have all those excellent experts around, and that's a very good opportunity to ask questions towards those topics. Okay, so with that, I want to start the first part about the standardization activities. And so the first speaker is Hao Jin from the CAS Quantum Network, and he will be telling us something about the activities for standardization in the ITU and ISO groups. So welcome very much to Hao Jin.
Okay, thank you. Can you hear me?
Yes.
Okay, thank you. Thank you for the introduction. So I will share my slides. So can you see the slides?
Yes, we see your PowerPoint.
Yeah, okay. So can I start?
Yes, please go.
Okay, thank you. First of all, thanks for the organizer to introduce me, to invite me to bring this talk on standardization of quantum cryptography in ITUT and ISO. I think this is an important progress that recently has been conducted. My name is Hao Jin, and I work for GAS Quantum Network as a senior researcher. Before joining the company, I was a postdoc in Waterloo and a PhD student in Telecom Paris, both on QKD. So I have the background in both academic and the industry. I'm also a contributor of several work items in ITU and ISO, and serve as a liaison officer. So today we are going to talk about the progress of QKD in ITU and ISO standardization progress. So as we know that QKD is a mutual technology that has been achieved many fruitful results since its invention. So we have commercial product, and we have QKD network implementation, and we also have QKD in space. In order to further expand the usage of QKD, one important topic is standardization. So in particularly, the international standardization is very important. So there are so far 3 important international organizations. So first one is International Organization for Standardization. I guess this ISO, everybody heard about it, and it produces many standards in our life. Is the second one is the International Electrotechnical Commission. It deals with the standards mainly for the electro and electronic related technology. And third one is the International Telecommunication Union. So this is actually the first global international organization and also the first standard organization. It is a special agency of the United Nations for the information and communication technology. So recently we have conducted several QKD standardization activity in this SDO. The Martin from SC will introduce the work in SC in the next talk. So in this talk, we are mainly focused on ISO and ITU. So for the ISO, it's actually the ISO IEC Joint Technical Community on the Information Technology, which has one work item on the QKD implementation security. To be noticed that there's also activity on post-quantum cryptography and quantum computing in ISO. So another important progress is from ITU that in several groups there's conduct activity on the standardization regarding to the QKD network on the network aspect and the security aspect, as well as there's a newly established focus group on the quantum information technology for networks, which actually a pre-standardization group to pre-study the standardization issue. So I will summarize all this activity in this picture. So this picture is actually the figure from one of the recommendations produced by ITU SG13, which is Y.3800. This is the first international standard for QKD network. So this is a QKD network based on trusted node. Actually, this is very similar from what previously academic proposed. It has several layers. So the standardization activity conducted by ISO and ITU is first for the ISO, it's on the QKD module security test and the certification method. And on the network part, ITU SG13 conduct the study in the part of network, all this network aspect. And SG17 deals with all these security requirement related issue. So I also mentioned the pre-study works carried out by a focus group from ITUT. It's also it addressed the issue in the different layers. For example, the user case for the application layer, the classic protocol in the control and management layer, and also the QKD protocol and transport technology in the quantum layer. So I will go one by one to introduce this progress. So first, we go to the ISO work item. So this ISO work item actually address one of the most important issue for QKD, which is the implementation security issue. So it's a high-level framework under the common criteria framework for the security evaluation of QKD module. So actually, if you have worked with information technology, common criteria, it's a very universal framework for the cryptography system and the security system. But there's this gap that in such framework, the QKD part is missing. So this work item is aims to build a baseline for this security work. So it will serve as a baseline for the further security function requirement for the protection profile and the security target when we look at the specific certification. So this work item has two parts. First part is the requirement. Second part is the test and evaluation method. So we consider the general model for the QKD a transmitter and a receiver. So all these yellow box are the one we consider for the first part, analyze the threats and impose a related security function, and also for the part 2, it's the security evaluation method to address those threats. So this is pretty much the ISO work that has been initiated from 2018 and now it's under development. So let's move to the network part. So this is only a work item from ISO. So let's move to the ITU part. So the first part of standardization is in the SG13. This group mainly deal with networks issues. So probably it's a good place to conduct QKD related standard development. So in the question 16, it's mainly deal with architecture, framework, and function requirement. This related technology on the QKD network. In the question 6, it's mainly due to deal with the quality of service on the network part. However, there are some recommendation or standards seems a bit advanced. For example, this one for machine learning based QoS for QKD network. I think this one is a bit advanced even for academic. Nevertheless, in this group, it has already published 2 recommendations on QKD network, and for other 3 on the key management and other layer has been consented very recently. So another group which study the QKD standardization is in SG17. So the topic of this group is on the security. So actually, quantum noise random number generator is also in the scope of the study area of this group. So actually, the first published international standards from on the QRNG is from this group. Also, on the other than that, there's several security-related standards on the QKD network, including the overall requirement, key management, trusting node, and so on. So in this group, it's mainly deal with the security aspect. Then we go to the last group that I mentioned before, that it's for a focus group on quantum information technology for networks. So this is actually a preparation group for the standard. So it does not produce any standards, but it will do some pre-study and pre-standardization activity, which means it will do the gap analysis, do the technology status review, do the standardization analysis, and give some future suggestion. So the output of this kind of group, it's a technical report, which with no normative contents. And it's a good platform for academic, industry, governments to join. So it was established from last year, and we already hold 5 meetings, including 4 e-meetings. In this group, the working group 2 is on the QKD network topic. So in this part, we have several interesting topics, including the terminology and the use case. Also the QKD network protocol, including the quantum layer protocol and classical layer protocol, as well as the transport technology, and also another report on the standardization outlook. So who are the main participation from these activities, standardization activity? So actually we have quite a few of participants from all over the world, from Asia, from Europe, North America. So some of them are already in the field for a while, some of them are new. So people may ask how to participate into this activity. So there are several ways. So for the ISO, it's for restricted to the experts for each country's national body. And for the ITUT, it's based on the membership base for the study groups. But for the focus group, it's an open platform that is free of charge for everyone. And it has newcomer friendly and flexibility for the newcomer to join the activity and to learn how to formalize the standards and to give suggestions for the future work. And it covers a wide range of topics. Also, there's possibility if you work in some other SDOs, the lesson channel is also a good way to notify or give comments to other work items in different SDOs. So in the end, so we have we want to summarize what has been done so far in this different group. So around the topic of QKD network. So as we can see for the ISO, we have QKD module security. And for the ITOT, we have security and network aspect. For the focus group, we have other interesting topics related to protocol transport technology. Of course, there are some other topics not covered yet. So at this particular moment, it will be interesting to look at the coming 5 years. There could be more potential works in different SDOs to further develop the standards of QKD related technology. This is my talk. Thank you.
Thank you very much. Thank you very much, Hao Jin, for this very nice and informative talk. Now I think we have time to have some questions for this talk. So if you have some question right now, you can just type them into the question and answer box you see in the right left corner. Maybe I will start with one question. So there's also, when you look at security aspects, there's also a lot of national aspects you have to consider, right? And national certification rules and so on. So how do you try to make this kind of compatible with those rules, which might vary, right? Very much.
So for example, for the QKD module security evaluation, so actually it's under the common criteria framework. Actually, this is a method used by many countries. So what we want to do is to fit for the current system, to fit QKD inside, instead of create a new framework, particularly for QKD. So I think as long as the country consider the common criteria approach, so this kind of standard in the future will be somehow compatible with your country's evaluation and certification method. That's my feeling. Thank you.
Mm-hmm, mm-hmm. So is there any other question? Always have also time to think about it, and we can ask questions later on in the discussion. Then I would thank you very much, Hao Jin.
Thank you.
So there's a virtual applause now, which is of course complicated to do in the virtual session. Now the next speaker then is Martin Ward from Toshiba Research Lab, UK, and he's talking about the standardization activities from ETSI.
Hello, everyone. Thank you very much for the opportunity to talk today and describe what's going on in ETSI at the minute. So I'm currently the chair of the ISG there. The ISG has been working on QKD for a number of years now, focusing on three main areas. So our activities are on security, so both the practical solutions for secure implementations, and also focusing on now evaluation and certification aspects. Second area is metrology. So this is related to security in many ways, knowing how components and systems are behaving. These often require measurements at the single photon level, and there are a few existing standards available for some of those tests. And then thirdly, we have networks and interoperability. So integration into conventional network infrastructures and interfaces to promote adoption and interoperability and development. So initially, I'm going to talk about security. So QKD is a rather unique security proposition. It's quite different from things that have been certified before. So in terms of taking devices through the certification process, there are lots of new challenges, both for companies presenting devices, but also for the national bodies and certification labs to evaluate them. So it's very useful to have specifications that have been reviewed by a wide range of experts. That's going to help ease the sort of facilitate the certification process. So also certification security analysis systems needs to consider all aspects of security. So we need to put in experts from with a range of established security skills. In addition to those with QKD expertise. So the new kind of activity within the ISG on security is that we've started to write a protection profile for QKD systems. So this again has been written, as Hao-Chin was talking about, the common criteria frameworks. This is also one of the common criteria frameworks. It has broad applicability. The work's being performed in collaboration with BSI Germany. And we're employing an experienced certification lab to help with writing the technical writing to make sure it's set out all correctly in terms of common criteria standards. So we're going to consider prepare and measure protocols only in the protection profile. And the target of evaluation that we're considering is that of a pair of QKD modules. So it's really a point-to-point, the basic sort of point-to-point security that we're considering. So we think that the protection profile is going to take around about a year to write. So we're expecting to finish that around summer 2021. But in addition to this, we'll also be working on a number of additional group specifications that can be used as background documents for people who choose to take to base security targets on the protection profile that we're producing. So a document that we published a while back was on security proofs. So really looking at a security framework for statements of security on QKD implementations. And the minute we're updating that, having another look at some of the things that have evolved and revising some of the definitions in it. So that's an ongoing task that's coming to conclusion around about the next month or so. I mentioned background document. So we have one document analysing implementation security of against Trojan horse attacks protection that you can have in one-way QKD systems. So in this document, where we're analysing giving design guidance and passive countermeasures against attacks. So this will be one of the documents that will be a potential background document for people to use if they're writing a security target. I would just highlight a white paper that actually produced a couple of years back, which gives a nice introduction to some of the challenges and solutions to implementation security issues. And then one other piece of work that we're looking at starting a new work item on at the minute is on the design of classical interfaces for QKD systems that include authentication. So obviously authentication is a key part of any QKD protocols, and it's also critical in terms of the interfaces that a QKD system is going to present. So we'll be looking at protocols used in discussion channels and auxiliary channels, management interfaces and key delivery interfaces. And authentication schemes such as Wegman-Carter for discussion channels and related systems, and also appropriate uses of public key algorithms in QKD systems. So the related area I mentioned was metrology of components and systems. The reliable characterization is critical both for security analysis, but it can also be useful for help to stimulate and develop the supply chain for components for QKD systems. It's important to understand and be able to specify what you want when you're building systems. So we're fortunate within the ISG to have a number of national metrology institutes involved in this work. So a few years back, we wrote a group specification on component characterization. So taking the measurements you need to do on individual components that are going to be systems are based on. So that's quite a detailed document. And again, was driven by some of the NMIs within the ISG. At the moment, we're working on a document looking at the characterization of the optical output of QKD transmitter modules. So there are a number of additional challenges when you start to try to measure things within a complete QKD system. You've got interferometers and things sitting in front of your components, and you have to think about how you extract information about what signals are being sent. So that's a development document that's running at the minute, and we'll then probably this year, we'd expect then to move on to a document looking at QKD receiver modules. So in terms of networks and interoperability, so obviously an isolated QKD link can serve certain use cases, but many require you to develop larger networks. Within the ISG, we currently consider that it's too early to start looking at interoperability down at the quantum channel level, but systems still need to be able to talk to each other, and you can construct a QKD network with multiple vendors in the system, as long as they can then talk to each other. So we need external interfaces and links to management systems. So in terms of actual APIs, we have a couple of APIs for people to use to extract streams of keys. So first of all, a low-level function call-based application interface that we published back in 2010. That's just updated. That has just been approved and should publish in the next week or so. We also have a REST API over HTTPS that's been used by, it's implemented in a number of QKD systems, and also a number of cryptographic applications like link encryptors. And it's very easy to use, low barrier to entry API for requesting keys from a QKD system. The other area that we're actively looking at is interfaces for use where you start to integrate QKD into SDN. So software-defined networking is becoming important in many areas. And we have one document that is coming to a conclusion, looking at the control interface, so the interface between the SDN controller and an SDN-enabled QKD module. And we're just starting another work item to look at the kind of northbound interface of that. So an orchestration interface between the QKD controller and the SDN orchestrators, looking at a number of distant aspects. And both those documents will look at the workflows and resources and performance and reporting and so on that's necessary. And that one is just starting, as I said, and it's due to finish in September 2021. We have also a look at more generally at network architectures that can be used in QKD. So we're writing a group report on this, analysing some of the experience that ETSI members have, looking at a range of different schemes and components within those, and how components need to talk to each other within a network. Okay, so the ISG is an international, ETSI is an international member-led SDO. Its documents are available to download for free. And it has a range of experts across manufacturers, system vendors, operators, academics, and NMIs. And we have people, we have active members from many different countries around the world, so it's not limited to Europe. And membership of the ISG is open to anyone, and it is possible to participate whether you're an ETSI member or not. Yep, people are very more than welcome to look at the website or to contact me if you're interested in more information. Thank you.
Thank you very much, Martin. Also here the talk is now open for questions. If you have some questions, you can type them in the question and answers, or you can think about some questions for the discussion round later on. Maybe one question from my side, and that's maybe a big question. So we heard now the talks from ISO, ITU, and ETSI, and there are, of course, some, I would say, interfaces, right, where you can interface the different standardizations. So how is made sure that these kind of interfaces work out well?
So yes, obviously so both the ISO document and the protection profile that we're working on are written under common criteria. So we hope that those can interface quite well, and that you can you certainly be able to use the ISO document as a minimum, as a background document if you adopted the protection profile. It's a challenge to try to harmonize, but we have people who are active in both groups, and we're looking to try to ensure that you can use the documents as much as possible together. I think it is. There are lots of challenges in terms of thinking about terminology, for example, making sure that if you use the terms in the same way across the SDOs, it's going to make it much easier for us to use these documents in combination and to reference each other's documents. So I think I didn't mention it, but one of the things we're working on is a bit more of a review of terminology and updating our vocabulary document and trying to ensure consistency within ETSI documents, but also talking to the other SDOs to try to ensure that we use certain terms that are critical in a uniform way. And also for QKD experts, we have to think about not only using terms in a way that we understand within the QKD community, but also to make sure that we use them in ways that are consistent with the ways that they're used in existing security fields at the minute. So I think that's an important challenge in terms of making these documents work practically together.
Mm-hmm, mm-hmm. Okay. If there's no more questions so far, then thank you very much for this very nice, interesting talk. And then we will proceed to our next part, and that's kind of an update about projects worldwide. So about testing quantum cryptography in networks. And so I'm happy to introduce the first speaker, that's Cheng Shipeng from USTC, and he will tell us about some activities in China right now. Please. I think we can't hear something. So maybe your microphone, you can check, you can double check. So we can see your screen, your shared screen, but we can't hear you. At least I can't hear you. Christian, is that the same for you about the audio?
He is unmuted, but we cannot hear him.
Yeah, so maybe we have another speaker first.
Yeah, maybe we can. So Cheng Shipeng, we see your slides and you're unmuted, but maybe if you speak something, because I thought I did see some signal on the virtual microphone, but
we also had video before.
yes,
We don't have that anymore.
Some signal, but so maybe we do first another talk, and then maybe you can just log in again, as always in computer systems, restart. And something doesn't work. It's a universal.
This is the same I did before. So Christoph, maybe I could start.
Yes, that would be perfect. So then let me introduce Andreas Poppe from the Austrian Institute of Technology, AIT, and he will then be talking about what is happening in Europe with the Open QKD initiative. And then later on, we will then hear about the Chinese activities.
So can you hear me and can you see my screen?
So the screen is still from Cheng Shipeng. Okay, now it goes. Yes.
Okay.
Yes.
Okay. Yes. So also the system tried hard to kick me out. Hopefully, I can restore it well. Yes, my name is Andreas Poppe. I'm at with AIT again, and we are the leader of this big EU QKD testbed project with the name Open QKD. So, but let's first go a little bit back in history. So between 2000 to 2010 or so, the community could successfully demonstrate a series of QKD network demonstrations, which really led to some nice, highly cited papers. But at the same time, these QKD demonstrations totally failed really to open a market and attract some users from the security community, and also tells the telecom community that QKD maybe needs some different ways to transmit the signals. The EU waited another 5 to 6 years or so, but luckily they changed somehow the mind and restructured the funding possibilities for quantum technology completely. In the center, we have this QT flagship projects, and we have different pillars. I'm sure you know this picture. And one of the projects out of the communication pillar, which is anyhow most suitable to talk about, is CIVIC. Just allow me one single slide, because at this time, starting in 2018, we already included 3 telecom providers in this flagship project. They are Telefonica, Orange, and Deutsche Telekom, in order to think about how to transmit the signals in the network, and together with them, and this was a work together with Deutsche Telekom, we made a kind of reference network and tried to find out how to distribute the QKD systems that the telecoms by themselves can use the keys to secure management plane, control plane, and the data plane. But this is, of course, was too less, and very luckily, there was the next step. It was this project, which is here called an Open QKD. It's a QKD testbed project, which has not the goal to have one single testbed somewhere, like you know from China. Maybe you hear the talk later on, but we want this would not match to the European structure. In Europe, we have many different groups around, equally spread nearly, and so the idea was really to build up even now 16 different sites where we have deployed fibers and want to put the QKD systems there, and not only go to the telecom use case we already have in Civic, but also find out what is the demand of the security community in order to really use QKD systems at the end. When you put all the logos from the 39 partners across Europe, it's really right impressive, but it's also a big and a little bit complicated project, of course, then, but the main aims are, of course, to raise awareness for QKD. We want to make clear the community and the users that they should also consider QKD for high-end applications. And of course, EU is processing more and more to this EU big quantum communication infrastructure project. So we have telcos, we have QKD developers, suppliers, end users, academic groups. So this is really a nice mixture. And when you look to this European map, you can see the different test beds which are distributed nearly equally around Europe. We have some larger ones, some smaller ones, but the aim is really to be close to the different developers, close to the users, and not that some users or use case need to travel across Europe. We want really also to extract attention to newspapers in order to give really a big shot that QKD is spread out as much as possible. What is the state of deployment and the production? So up to now, we have really 25 QKD links already produced, but they're not spread out of for Europe because, of course, the Corona crisis hit us really hard. So we are behind 3 to 6 months, but we need to try to catch up. We also have some encryption devices, and we work on the second generation QKD systems and the key management, which was also somehow connected to the talks you heard before with the standardization. We have already one test bed running in the field. This was Geneva. This was easy in that sense because ID Quantique is the main QKD supplier, is really around the corner, and there are some small telecom operators there, and they really use QKD system now for their use case, also for instance for data centers. We have some upcoming use cases, Graz, Madrid, and Berlin. I just only want to briefly show one slide about Graz. So it's not fully clear, but here we have 4 links. It means each link consists for 4 dark fibers, and we populate the QKD systems and the telecom systems in there in order to do some secret sharing. We have high volume pictures from really patients, but we cannot use them, unfortunately. We distribute them to different cloud storages, and the user need to get the data then from the storages again. So this is my last slide. I just want to point to our newsletter. We really need to start it now. We'll also lag a little bit behind on that. We have a quantum industry board where we still search for participants. And what we also finished now was the first round of open calls. And we have a second round, and we have still some money left to distribute it to the main EU researchers, and so please stay connected with us that we can inform you about all things which are going on. Thank you.
Thank you very much, Andreas. So very interesting. So this talk is also open for questions. So while Chengshi tries to reconnect, I think, as you said, Andreas, there's some problems sometimes with the connections, right? So we can, but let's see.
Yes.
So maybe I can ask one question. So right now we see that there are some activities, all international, going on. Is there some ideas to also potentially look for use cases connecting intercontinental links, the different test beds, so to say?
Yes. So yes, we also have some satellites research organization, not really providers, but as you know, this is then for the next step, this QCI project, which has not only a ground space, but also space-based links there to connect different metropolitan areas, connect different users together and so on. And this is anyhow the good question. And for me, it's still open to run if, for instance, a large metropolitan area, even in Europe, like Berlin and Madrid or Paris or so, will be connected first over satellite, over direct trusted repeater link, or already over the quantum memory-based real quantum repeater. So this is a really exciting time now.
Mm-hmm. So there's one question from Vadim Makharov. So he says, seems there are small networks only. Will there be a larger EU network, a backbone?
Not yet, not within OpenQKD, because OpenQKD don't have enough money really to deploy a lot of systems. We first go to the users and to the metropolitan areas in order to connect them first, and then try to connect the different metropolitan areas together, as I mentioned before.
Mm-hmm. Okay, thank you very much. So if there's no further questions, we still can have questions afterwards for discussion time. So how about Chengshi?
Hello.
Okay.
Now it's okay. Okay.
Very good, very good. So apologies for the technical troubles, but yeah, that's the usual thing. So very nice. So now we come to the talk by Chengshi Peng from USTC, and he will update us about the activities in China. Please.
Thank you. Good afternoon. I'm sorry about my computer. I am Chen Zhipeng, coming from University of Science and Technology of China and CAS, and also come from the Quantum CTech company. Here I will mainly introduce our recently work about the practical space ground integrated quantum communication network. As we all know, MORS satellite has been successfully launched for nearly 4 years. With this satellite, we have implemented a series of satellite ground experiment works. On the other hand, we have already built the longest QKD fiber network in the world. It is from Beijing to Shanghai, with total length about more than 2,000 kilometers. The Beijing terminal is already connected to our Xinlong ground station for MORS satellite. The combination of Beijing-Shanghai fiber quantum network and MORS satellite let us have a chance to show the feasibility of the ground quantum network. However, there are still many difficulties and technical challenges to be pushed in the future of realize the real practical quantum communication network. For example, our MORS satellite is a low Earth orbit satellite. It moves fast, which makes the experimental duration only about 6 minutes per orbit, and it have to work in the night. Therefore, in order to realize the truly global quantum network, we need to make efforts in many aspects, such as quantum stellation with LEO nano satellite, or the high orbit quantum satellite, and upgrade the present quantum network. The first thing we have to do is to develop the quantum stellation with low orbit nano satellite and low cost compact QKD payloads. Recently, we will carry a compact QKD payload with about 30 kilogram on the standard satellite. Meanwhile, we are also promoting to our own quantum nano satellite project. It will launch 3 or 5 satellites in 5 years, will service more than 100 users. Also, here is the big progress. We will design the low cost ground station for quantum stellation, because we know the ground of a lot of user. We expect a lot of use our satellite. We will make the ground station. We will make the ground station smaller, lighter, and cheaper. In other words, the ground station will be easy to place, install, and use. With this compact ground station, we have totally completed many times satellite to ground QKD and different cities, such as Shanghai, Jinan, Weihai. Here is a short video of rapid deployment in Jinan, and in 1 day, performing the satellite-based QKD with the compact ground station. In order to overcome the problem of short time duration and small coverage range, the second thing we will plan to do is the high orbit quantum satellite. It will focus on the all-time or all-day quantum communication. Using the MEO or GEO satellite, the communication time during one transmit will be increased from minutes to hours. Furthermore, if we can break through the Earth shadow limit, we will be able to provide 24 hours service of key generation for some specific areas. For the payload, in order to overcome the higher China loss caused by the increase of orbital height, we need to develop a higher brightness spaceborne quantum light source, like include the decoy stage source and the entangled phantom source. For the GEO satellite, the big optical telescope on the ground also should be upgraded. In order to reduce the background noise greatly, we have to use a single mode fiber to receive the photons to reduce the field of the view of the receiver. So, due to the atmospheric turbulence, the coupling efficiency of single mode fiber will be very low. To overcome this problem, we should develop the adaptive optics to achieve enough coupling efficiency. On the other hand, the present fiber-based network in China also needed to be upgraded. The goal of the upgraded backbone network will be safer, faster, and wider area. A new protocol, such as MBI QKD and TF QKD, can be developed to offer a better security and great transmission distance. Recently, my college achieved the entanglement of 2 quantum memories via fibers over 10 kilometers, which enable the repeater-based quantum communication, paving the way towards building a large-scale quantum networks over long distance. For more detail of this new progress, you can find the corresponding talks of my college. Moreover, several new quantum backbone are planning to build a nationwide fiber network to connect most of provinces in China. Beyond that, we can also try to perform China integration between QKD and the classical communication. For instance, we have realized the China integration between a commercial QKD system and a commercial WDM system over 110 kilometers, together with China Telecom, Fiber Home, and so on. For Chinese QKD industries, under the support of the CAS and USTC, we founded 2 companies. One is the CAS Quantum Network. The company is focused on quantum network construction and operation, and promoting the wide application of quantum safe technologies. Dr. Qin Hao has just given a talk on the QKD standard on behalf of CAS Quantum Network. The other is the Quantum C Tech. It is a Chinese pioneer and leader in commercial quantum information technology. Now maybe the biggest manufacturer and provider of quantum information technology product and service. Up to now, we have a lot of users in our fiber network, including one of the biggest bank of the world, ICBC, for data disaster protecting, and one of the biggest internet companies in the world, Alibaba, for data security. We have completed the chain of QKD industrial standard application in China. Finally, in a summary for the future large-scale quantum communication in low orbit, we needed to develop cheap nano satellites to cover the Earth. To construct cheap and ground station, we also plan to develop high Earth orbit satellites to provide 24-hour service. We expect the lower cost of the global satellite and fiber-based QKD, perhaps less than 1 cent per kilobits all over the world. When we lower the cost of the price, a lot of security applications such as authority, bank accounts, online meeting, and other information security requirements will prefer to use QKD. If you can make the global quantum communication much cheaper, much safer, and much convenient to use, we can make it be the best choice for the future information security. This is our homepage and QR code. Welcome everyone to contact us. Thank you.
Yeah, thank you very much. Thank you very much, Chengxia. So very nice talk. So we are open for questions. So you can type it in the question and answers as always. Maybe I start with one question. For the satellite project, if you want to go for a geo satellite, so how big would you expect the apertures from the telescope to be, so that you can deliver a key?
On the satellite, the telescope maybe 1 point, or maybe not, will be about 0.5 meter or bigger. Such as this. It is a general telescope technology on the satellite. We know now the biggest satellite telescope is about 10 or more meters. So 0.5 meter is not a very hard thing.
Okay. And maybe another questions before I see other questions popping up. So can you imagine also a kind of international roaming, connecting the Chinese network to other networks via some means, some channels?
I think our QKD technology is another choice, is different choice with the like a RSA, like a mass mode, or you a key transmission mode. So it will get if we and QKD method can use with can similar combined with the communication, like fiber communication. So the Chinese QKD network, like the fiber communication, will connect to the all of the world. It is I believe the QKD technology will combine with at least communication and with one device can provide the key transmission and communication. This is a basis, is maybe a communication base of the internet.
Okay, thank you very much. So if there's no further question right now, then thank you very much for your nice talk.
Thank you.
And so then we come to our next talk, and the next talk is by Yoshimichi Tanizawa from Toshiba, and he will tell us something about the activities initialized in Japan. Please.
Oh, thank you for the introduction, and thank you for this opportunity. So in my presentation, I would like to explain the Japanese two national projects. One is a SIP project we have now conducting, and another project is global quantum network technology we have started now. So this slide shows the SIP project we have started from 2018, and it has 3 topics, and our team is focusing on the photonic quantum communication, and commissioned by the Cabinet Office Japan. And this slide shows overall layering architecture of the research target. The bottom layer is a quantum layer, so the QKD unit is located here and exchanging key. And the intermediate layer corresponding key management layer and the quantum QKD network control and management layer. In this layer, the key management agent manages keys from the quantum layer, and trusted node is located here and consists of key management agent and several QKD units. And the key management agent exchange key management information between other key management agent on the different trusted node via authenticated line. And the upper layer is application service layer. The key is provided from the key management agent to the application here. In our research target, we assume special types of application, secret sharing. Secret sharing is a technology for distributing data amongst a group of participant application here, and each of whom is allocated a share of the data, a part of the data. And the data can be reconstructed only when a sufficient number of shares are combined together. And the individual shares are of no use on their own. So in this project, we are trying to develop, integrate quantum cryptography technology as information theoretical secure communication and secret sharing technology, information theoretical storing technology, to develop, we call this technology as a quantum secure cloud. So this map shows 4 trials we are conducting. And in my presentation, we focus on these 2 trials. One is a biometric authentication data field trial, and another is a genome data field trial. So this slide shows a biometric authentication data field trial, and it focuses on the face authentication system, a user-friendly personal authentication method. And the figure shows an image of the face authentication system and the example of the system screen. In the face authentication system, reference face data is needed to be stored, and reference data should be referred. And this reference data should be protected, protection element under law. And apparently, the biometric data cannot be changed even the data are stolen. So the face authentication system should be protected by quantum secure cloud technology. This figure shows overview of the face authentication system. In installation site, cameras are monitoring someone entering, who are entering. And when detect someone is entering, the camera and the processing servers send detected data to authentication server and referring database containing reference data and identify who is he. So this figure shows overall architecture of the trial system. With this system, the biometric system with quantum secure cloud technology protects the real data. Real data means a Japanese national sports team data. I would like to explain this number 1, 2, 3, 4, 5 in this figure. So in the step one, the access control area, the camera detects someone is entering here, and the detected data is transferred from the camera via system control server to the data server. And this communication is secured with the QKD technology with one-time pad. And here at the data server, the database reference data are stored in a distributed manner using secret sharing technology. And when identify the user accessing here and allowed by the system, the user can access to the stored data here, the medical record data. And medical record data also stored in a distributed manner using secret sharing technology. And in step 4, this system also allows to access from the mobile PC to the data. In this case, the machine authentication and user authentication, including face authentication, should be performed on the mobile PC. And the data between the system control server and the mobile PC is secured by pre-shared key, not QKD, but this technology allows to access from the mobile PC. So next, I would like to explain another trial about the genome data research and medical domain. As we know, the genome data is very important for the genome medical and genome researches. And also, at the same time, genome data is very sensitive. for the personal, for each personal. So in this situation, we have developed genome data transfer system using QKD technology and one-time pad technology. This research activity is a collaboration research of Toshiba, Tohoku University Tomo, and Tohoku University Hospital. And there are two sites, Toshiba's site and Tohoku University site. So the use case is as follows. The genome itself is delivered from the Tohoku University to the Toshiba's site. In Toshiba's site, the next generation sequencer is sequencing genome itself and generating the genome analysis data. At the same time, the QKD system transfers the genome analysis data to the Tohoku University as a result of the genome analysis. And the genome data is very huge. So we have 4 trials here, and we use different kind of genome sequence method. Trial 1 and 2 use a whole genome sequence, and it's in this case, genome analysis data correspond to the more than 500 gigabyte. And trial 3 and 4, we use a whole exome sequences. In this case, the genome data correspond to be 18 or 19 gigabyte data. To support this huge data transfer, we use our high-speed QKD system. The average security rate was 7 or 9 megabit per second here, like this. And this was a case trial where the actual first case where the actual genome analysis data transferred using a QKD technology with one-time pad. And please visit our team's poster, ID 117. This poster describes more detail about this trial. And another trial related to the genome data research and medical area is TB conference system for clinical use. So medical experts, including doctors, need this kind of TB conference system for discussion and genome data reference of patient cases. So in this trial, there are 2 sites, both the Tohoku University, Tomo, and hospital. Between these 2 sites, the existing TB conference system is connected to the key management servers, and the conference data, including movie and reference data, exchanged between the TB conference system by key management server. And the key management server performs a one-time pad encryption using a QKD key. With the result, the average key consumption of this conference system corresponds to the 1.05 megabit per second. Since our high-speed QKD system security rate is 10 megabit per second at the maximum, we found that our QKD system can support this TB conference system. And this was a trial where the medical expert, including doctor, joined and confirmed the validity of the TB conference supported with QKD system. Okay, and there is another poster explaining this trial. ID is 141. Please visit the poster. So this is a last slide, and we have started a new joint R&D project. The topic is Global Quantum Cryptography Network, and there are 4 targets. Target 1 focus on the QKD link technology for higher speed and longer distance, and target 2 focus on the trusted node technology, including system security to secure the node itself. And target 3 focus on the quantum relay technology to drastically expand the distance of the QKD link. And target 4 focusing on the network functions to support wide area and large scale network. We have started this R&D project as well as continuing SIP project for the several kind of field trial. Thank you very much.
So thank you very much for this very nice talk. So again, the talk is open for questions. So you can write questions in the question and answer box. So maybe I start with one question. So when you have those medical examples of using QKD links, so what would you say is the greatest challenge to bring that into kind of every hospital or every doctor's practice that could use it?
Okay. So okay, so this case, the distance between these two sites is 7 kilometers, so relatively short. So that's why we could achieve this speed. So one, as usual, as one of the recommended feature for the QKD to apply for the actual area is the speed of the QKD secure key, right?
Mm-hmm.
Yeah. And okay. And sorry, with these two field trial for the genome high volume data transfer and the TB conference system. So this is a very short and quick responses needed. So with these two field trial, we confirmed that QKD technologies can be supported to this kind of two different types of application. That was a good point, but I think.
Okay, so thanks. There's one question by Yong Chao. It reads, "Thanks for the nice talk. I'm wondering whether the encryption of the data using QKD and one-time pad or QKD and symmetric algorithm is used."
I'm sorry, I don't understand. Well, I don't understand
so
what.
Basically, the question is whether the encryption of the data that was used in these use cases was using QKD keys and one-time pad or QKD keys and symmetric encryption.
Okay, so in these all cases, we use a QKD key for the one-time pad technology. Yes.
For the one-time pad, so the data the data transmitted is using a one-time pad, not an AES symmetric encryptors.
Yeah, data is encrypted using one-time pad technology.
Okay. There is another question by Wolfgang Gerke. Is today a commercial QKD system from Toshiba available in Europe, as far as you know? So that's a very commercial question.
Yeah, we are not yet. Not yet, but yeah, we are investigating to start business very near future.
Yeah.
Thank
you very much.
Thank you.
Okay, so thank you also for this very nice talk. And so now we have the open discussion session. And so feel free. So we have now the opportunity, we have very good experts here that you can ask questions about all those topics. And as we learned, those topics are, of course, a little bit connected: standardization and networks and the deployment of all those technology. So maybe you can just type in your question in the question and answer box. Before, so maybe I start while you can think about questions. And what I always like when I have such experts here and around, I would say, okay, if you would have a wish, a quick wish, right? I mean, sometimes you can, there's someone who just gives you a wish, So what would you wish to accelerate the deployment of QKD systems? So maybe, I don't know, how Chin, we start with you.
Excuse me, it start with, you said it start with me?
Oh yeah. So the question is, so maybe all the panelists. So the question for everyone would be the same. If you would have a wish free, right? If someone would fulfill you a wish, what wish would you kind of have to accelerate the deployment of QKD?
Yeah, Christopher, so may I start? I know my wish already.
Yeah, sure.
Yeah. Yeah, I guess that everything is really a complex ecosystem, and when you take out one wish, it will not happen because the other things are still the problem. But I would really wish that photonic integration would work for QKD, enabled to have a cheap QKD system, which is also compatible to the QKD, no, sorry, to the telecom standard, REX and so on, that the different big vendors, Nokia, Ericsson, plus the Chinese ones, of course, can really integrate it in their systems and operate it.
So, who would like to answer next?
Maybe I can give some comments. So I have same kind of feeling that QKD in the future should be part of the information technology infrastructure, like to be combined with the operator, telecommunication operator. So as today's RSA and AES, this kind of technology, in the future in certain critical infrastructure, the wish is that QKD can be real, like replace some of them and to be like really put in practical use and to make its advantage to serve for our future network and other information infrastructure. Yeah, that's my wish.
May I?
Yeah, sure.
Yeah. So I think I hope many people from the various background would join the R&D and the business of the QKD area. So I think QKD area requires very broad technology, and very broad knowledge. So I hope for example, network technology and also the many types of IT technology researcher or engineer would be welcome to join this field. Thank you.
I don't know, maybe Martin?
So I think those points are right. So I think probably we can survive without integration between QKD systems at the link level, but the integration into the networks is what really is important. So yeah, compatibility with existing networks, integration with data. I think those are the most important points to get things integrated. And then I think, yeah, the sort of certification side to give people the assurance that the systems have been worked through properly and that they can have confidence in them. So.
Maybe Cheng Shou? Maybe there's some network problem. So I have, there's, okay. So Vadim Makharov posted, so he has a comment. I wish a whistleblower leaked that NSA has a quantum computer. That's, of course, it would be a boosting event, yes. I agree.
My answer is general quantum compute, general quantum compute under the combination with commercial fiber laser communication network and make the chip design QKD technology. If we have this, we both have this, then QKD is will be everywhere everybody and every country will need a QKD.
Okay, thanks a lot. So there's one question by Romain Leon. So Romain says, thanks for the nice talks. To build on the question from Yong Zhao, what is the view on the experts on this following controversial question mark statement? Combining QKD with AES, so the symmetric encryption, has limited cryptographic interest, right? So I think some people might claim that if you combine QKD with the information theoretical security with the symmetric AES, that it has limited cryptographic interest. So anybody want to comment on that?
I hope that the statement is wrong, but I'm not sure.
Okay, so basically it's really about the statement between the relation of this of QKD and the security promises of QKD and symmetric, and the use with symmetric encryption. Right.
I mean, when you look to the telecoms, you need, of course, to transmit a high amount of data. And QKD can maybe now get to 10 megabit per second, but will probably not go to 100 gigabit per second within shorter time, but telecom would like to have it. And then AES is really needed because then it's interesting really to replace the keys in a short fraction, say every minute or every half an hour. And I think then combining QKD with AES has hopefully commercial interest for secure applications.
Further remark on that?
So I guess hopefully this leak from NSA is of a finite size quantum computer. So I think the use case where you can change the keys rapidly, you don't have that the future loss of once you've been attacked, you lose everything. So I think that's the, at least in the medium term where QKD has limited bandwidth, I think that's certainly where potential interest may be.
Okay. All right. So I don't see any further question right now in the question and answer box. So thanks a lot to all the experts. Thanks a lot for your nice presentations and the updates. So I think it's always very refreshing and interesting what is happening worldwide. And it's good that we know what is happening worldwide. And if it is only to tell our governments that, there is something happening and we have to do something. So it was very interesting. And thanks for joining this session. And we will be looking forward to all the other talks at QCrypt.